Let's continue on with 6-2, Part 1. We're inspecting the equations before you try to solve a system is a strategic way to handle these problems. So we're going to be, without graphing, determining whether the system of linear equations has one solution, no solutions, or infinitely many solutions. So looking at D part, I have an equation x equals to 3, and I have an equation y equals to 4. These are our special lines. If you have just an x in your equation, I'm going to graph this for you just to show you how we would graph x equals to 3. X equals to 3 is going to be a vertical line. If you have just an x and not a y, it is a vertical line. So you go out on the x-axis to positive 3, and you draw a vertical line. So this is the line x equals to 3. Remember, this is your x-axis, this is your y-axis. Now let's graph the line y equals to 4. It is a special line. It just has a y and no x. Now, if you have just a y, this is a horizontal line. An horizontal line. So to graph y equals to 4, you go up on that y-axis, 1, 2, 3, 4, and you draw your horizontal line. So this is the line y equals to 4. Now I'm going to extend my vertical line up so that these two lines touch. So if you notice, a vertical line and a horizontal line will always touch. You may have to extend them up or out, but they will always touch. So the answer to this system would be one solution. So I have actually drawn that for you so you could see me graph a vertical line and a horizontal line. Their point of intersection would be the point 1, 2, 3 is your x value, and up 1, 2, 3, 4 is 3, 4. So actually, the solution to this system of equations would be 3, 4. It is one solution. All right, next, I want us to look at E part. E part has two lines, as you can see. We have two lines. They're not in the form of y equals mx plus b. So that's going to be the first thing that I'm going to do. I'm going to solve each one of these lines for y equals mx plus b so that I can look at their slopes. So let's do that. So I'm going to take 2x plus 3y equals to 6 and solve for y. So the first thing I will do is I will subtract 2x from both sides. Subtracting 2x from both sides. The 2x's cancel. So I end up with 3y equals 2. Now I'm going to put my x term next to the equal sign, negative 2x plus 6. 6 minus 2x is the same thing as negative 2x plus 6. I put it in this form, students, because I want it in the form of y equals mx plus b. But I've got to have a 1 in front of x. So to undo the multiplication that 3 is doing to y, I need to divide everything through by 3. The 3's cancel, so I get that 1y just like I want, equals 2, negative 2/3 x plus 2. So there is the first equation in the form of y equals mx plus b. Now let's go back and solve the second equation for the form of y equals mx plus b. So the first thing I would do I would subtract 8x from both sides because I want to get the y term by itself. The 8x's cancel. So I end up with 12y equals 2, negative 8x plus 24. Again, you want the y in front of the equal sign, the x directly after the equal sign. Now let's divide everything through by 12. If you divide everything through by 12, you end up with y equals 2, negative 8/12 x plus, what is 24 divided by 12? That would be 2. Now, I think we can reduce this fraction. I can divide both numerator and denominator by 4. If I did that, 8 divided by 4 gives you 2 on top. 12 divided by 4 gives you 3 on top, x plus 2. So ends up, I have y equals to negative 2/3 x plus 2. What do you notice about these two equations? Here was the first one solved for y equals mx plus b form. Here's the second one solved for yx plus b form. So these are the same line. These are the same line. So the answer to this system of equations would be infinitely many solutions. Infinitely many solutions. When you graph these two lines, you would graph one right on top of the other, therefore they would meet at each point. Now let's go back and I want you to just look at this problem. When I look at this problem of these two lines, I could easily see that if I multiplied this first line through by 4, I would get the second line. What's 4 times 2x? 8x. So if I said 4 times 2x, I'd get 8x. What's 4 times 3y? 12y. What's 4 times 6? 24. So when one line is a multiple of the other line, we know this is the same line. And that's the reason why that when I solved them for y equals mx plus b form, they were identical, they're the same line, and these two lines would touch infinitely many times. So we would have infinitely many solutions. Now the last problem we have is F, and F has x equals to negative 1 and x plus 1 equals to negative 1 and x plus y equals to positive 1. So we would need to solve these for y equals mx plus b form. So let's do that. So I have x plus y equals to negative 1 and x plus y equals to positive 1. So let's solve them for y equals mx plus b form. So the first thing I need to do is subtract x. So if you subtract x, getting the y by itself, you'd have y equals to negative x minus 1. As long as you have a 1 in front of y, you have solved it, and it's in the form of y equals mx plus b. So I want to do that to this line also. I want to get the y by itself. So let's subtract x from both sides. Remember, what you do into one side of the equation, you must do into the other. The x's cancel. You end up with y equals to negative x plus 1. This is a positive in front of 1. So I have to have negative. The negative comes with the x. Negative x plus 1. So comparing these two lines, I have y equals to negative x minus 1, and I have y equals to negative x plus 1. They do have the same slope, but they don't have the same y-intercept. So if they have the same slope, they are parallel lines. And where do these lines touch? They do not touch. So the answer would be no solution. So for F, these two lines have the same slope, but they have different y-intercepts. Therefore, both of these lines would be slanting downward to the right because of the negative slope. And these two lines do not touch, they're parallel.